Hello everyone, welcome to another video. Today I want to show you how to build a custom image and then use them in Managed DevOps Pools to run the agents. So the plan for today is I'm going to explain quickly what Managed DevOps Pools are. I also have a more extensive video about this, so if you haven't watched it, I will link it so you can watch it and learn all the details about it. Then we're going to create an Ubuntu VM and install Docker on it. Then we also create a Windows VM and install .NET 9 on it. Then we're going to create Managed DevOps Pools. Actually, we're going to create two, one for the Windows image and one for the Linux image. And then we test both with an Azure DevOps pipeline. Okay, let's get started with what Managed DevOps Pools are. With Managed DevOps Pools, that's an option to self-host our Azure DevOps agents. We have the option to use Microsoft hosted ones, but they come with quite some limitations, and so we want to self-host them quite often. And in the past we had to use VMs. The problem with this is VMs are expensive and we had to self-manage everything. This means install the VM, keep it up to date, keep it secure, and that's quite expensive and labor intense. And the advantage with Managed DevOps Pools is that Microsoft takes care of the VMs. So I just say what size I want, and then Microsoft takes care of everything else. So I don't have to update the VM. I don't even have to install the agent myself. Everything is done by Microsoft. And the big advantage is I only pay for the time I use the VM. This means if I start a pipeline, I start to pay. And if my pipeline finishes, I stop paying. The downside of this approach is that it takes a couple minutes for my pipeline to start. If that's not an option for you, you can also have standby agents. They're just running, but then you pay for them all the time. And with Managed DevOps Pools, we have two different kinds of agents. The first one are the Microsoft agents. There we have Windows and Linux agents. And these are the same agents we have for the Microsoft hosted agents in Azure DevOps. This means the most common software is already installed. Microsoft takes care of everything. And if we need more, then we can install it with the CLI. On the other side, we can also use our own images to host the agent. This might be useful or needed if you have software that can't be easily installed via CLI. For example, if you need a UI to install it, if you have special use cases, then you have to prepare the image yourself, and then you can use this image. And then Microsoft takes the agent, installs the agent on it, and runs the agent with your image. And in my opinion, this is the best option we have right now to host our Azure DevOps agents. And in general, I think that's one of the best services we have right now in Azure. And with this, I'm going to show you how to create everything, and let's dive into the terminal. Let's get started by defining a couple variables. So that's the name of the resource group, the name of the location, and a name for the gallery. Then we're going to create the resource group. And next up, we're going to create the image gallery. That's basically a storage container for our images. And we can also share the images with other Azure services. In our case, we are sharing them with the Azure Managed DevOps Pools. To create a new image gallery, we are going to use the AEC SIG create command. We provide the resource group and the name of the gallery. And then I'm also gonna query the ID and save it in a variable because we're going to need this ID later. Creating the gallery should only take 1 or 2 minutes. And the next step is to query the ID of a service principal. So let's clean up this window. And the service principal has the name DevOps Infrastructure. This service principal is created when you register the DevOps infrastructure provider, which you need for the Managed DevOps Pool. Again, if you have watched my video about Managed DevOps Pools and all the details, I will link the video again. And then we execute this command, and now we have the ID of the service principal. And we need this because we have to give this service principal read access to the gallery we just created. So we use the AC role assignment create command. Then we provide the ID of the service principal, the role as reader, and the scope, the ID of the gallery which we just created. And if you don't do this, then you will get an error message that's as unhelpful as it could be when you try to create a managed DevOps pool with your custom image. And this is necessary so that Managed DevOps Pool has access to the gallery which hosts your images. Next up, we're going to create the DevCenter, which takes care of the Managed DevOps Pools and manages the infrastructure and hardware in the background. So we're going to define two variables. So that's just the name of the DevCenter and the name of the project. I'm very uncreative, as you can see, but you can provide any name you want. And then we create the DevCenter. So you just use the DevCenter create command. We provide the name, the resource group, and the location. It's pretty straightforward. This should only take a couple seconds. And after we have created the DevCenter, then we're going to create a project inside this DevCenter. And this project will host our Managed DevOps Pools. With the DevCenter created, we can get now the ID of the DevCenter. And then in the next step, we can use this ID to create a project inside this DevCenter. So again, we use the AC DevCenter admin project create command. We provide the name of the project, the resource group, the location, the ID we just copied, and then a description so we know what this project is for. This should also take a couple minutes, and after this has been created, we can start creating our VMs. The project has been created, and now we have everything set up to get started with our first VM. So let's clean this up, and I'm going to define a couple more variables. So that's the name for our Ubuntu VM, the name of the admin user, and a very secret password. And with this in place, we can create our VM. So I use the AC VM create command. Then I provide the name, the resource group, the admin user, and the password. I'm using Ubuntu 24.04, but you can use whatever you want. And then I'm going to query the public IP address because we're going to need this in the next step to SSH into the VM. So let's create this. It should only take 1 or 2 minutes. And after this is ready, we can connect to our VM, and then we can install all the software we need and then use it in the DevOps pool. Now that the VM is created, we connect via SSH and we provide the user and the public IP address. And then we also have to provide the password. This time I have to type it or paste it. And now we should be connected to the VM in a second. And here we are connected to our Linux VM in Azure. And now you can install whatever software you need to build or to run your software. For this demo, I try to keep it simple. So I'm just going to install Docker. So first I'm going to download the Docker script, and then we execute the script. And I forgot to mention that, as always, I will upload all the code to my GitHub repository, the link to it in the description. And there you have all the commands I'm using in this video, and you can try it yourself. Installing Docker should only take 1 or 2 minutes, and after it's installed, I'm just going to check if there are any container running. And since I don't get any error message, I see that everything has been installed successfully. And for this demo, I'm already done. But as I said, you can install whatever you need. And once you're done, we can just exit our VM. And now we have to do 2 more steps to prepare the image. For Ubuntu, we have to deallocate the VM. This is basically stopping the image and taking it off of Azure. And then we have to generalize the image. This means that we can use the image for other services, like in our case, the Managed DevOps Pool. So let's deallocate the VM. That's just AC VM deallocate the resource group and the name of the VM. It should only take a moment. Now let's generalize the VM, and that's again the resource group name and the VM name. And this only takes a couple seconds. And now we are ready to use the image in our Managed DevOps pool. And usually I would recommend to do everything in the command line and as code. But for now I'm going to switch to the portal because I think it's easier to understand what's happening if you see it visually. Here in the Azure portal, we are inside the resource group we created, and there we have all the resources we created today. And here we also have our Ubuntu VM. And if you open this VM, we see on top the capture option. And we're going to click on it and select image. And now we have to provide the information where we want to store this image and some basic information. And we select, as it's already pre-selected, that we want to share the image to the gallery. And if you scroll down, we can select the gallery we created before. Then if you scroll further down, we have to provide an image definition. So we create a new one. And then we provide just some basic information. For example, a name. For example, my Ubuntu agent. Then some information is already pre-selected from the image we took from the VM we took the image. For example, that it's a Linux as OS type or a generation 2 VM. Then you can change the information of the publisher. You could enter your own information. And especially if you scroll down, you can provide some more information about, for example, privacy, contact information, if you want to share it publicly on the marketplace. For now, we just want to share it by ourselves, so everything is fine. And also the recommended resources like memory and CPU, we will leave as it is. So we create this, let's say OK. Then if we scroll further down, we can also provide some information like the default replica account or the default storage. But for the demo today, we just leave it as it is. Then we don't need any tags and we can create it. Actually, we cannot. Let's go back. And I forgot the version number. And the version number always has to be 3 digits. So I'm going to use 1.0.0. And I think this should be everything now. So let's see. And the validation passed. And now we can create it. And now the image is added to the gallery. This is going to take around 5 minutes. And I will stop the video and I will be back once the deployment is finished. After the deployment is finished, we can now create our Managed DevOps pool with the new image. So on the top, we search for DevOps pools and there you can find Managed DevOps pools. Then we click on create. Then we already have the information pre-filled of the resource group and the DevCenter and project we created before. Then we have to fill out the URL to our Azure DevOps organization. In my case, this is Programming with Wolfgang. And then we provide the name for the agent pool that will be created in Azure DevOps. So I'm just using Ubuntu MDP for Managed DevOps pools. Then the region, the same region as always. Maximum agents, I'm going to use 1. For the agent size, you can configure how many resources your VM should have. In this case, I just leave it as it is. The disk, I'm going to use SSD, so the build is hopefully faster. And then we come to the most interesting part, that's the image. So by default, Microsoft already selects the Ubuntu Server 2004 image, but we're going to delete this one. And then we add an image from the image library. And here we select Azure Compute Gallery Images. That's the gallery we created before. And if we open this, we can see we already have the image there we just created. So we select this one and add it. And that's basically everything we have to do. So there are way more options with Managed DevOps Pools, but again, I will link you the video where you can see all the details. For now, just let's create this one and create this. And now Azure automatically creates an agent pool in my DevOps organization. And in a couple minutes, I can run a pipeline and use this agent pool. Once the deployment is complete, we can switch over to our Azure DevOps, and they have already prepared a pipeline. So in this case, we're going to use the Docker pipeline, and I'm going to run this pipeline, and then we're going to take a look what's inside this pipeline. And the most important part of this pipeline is the pool. This pool has the same name as the pool we just created. The rest of the pipeline is very simple. It just looks for a Docker file in this task and then builds this Docker file. And what happens now behind the scenes is that the Managed DevOps pool sees that there's a new pipeline, and then the DevOps pool creates a new VM with our agent on it and then executes the pipeline. This usually takes around 3 minutes, but Microsoft says that it can take up to 15 minutes. So once the pipeline is finished, I will be back. Creating the VM took again 3 minutes, as most of the time, and as you can see, the pipeline executed successfully. And with this, I've shown that we created our own Ubuntu image, we installed Docker on it, and then Microsoft took care of the rest. We didn't have to provide a personal access token to access our Azure DevOps server. We didn't have to install or configure an agent. Everything was done by Microsoft. All I had to do is use the name of the DevOps pool, of the agent pool, and then I could execute the pipeline. And with this finished, now let's move back to the terminal and let's take a look how all of this works with a Windows VM. Back in the terminal, we define 3 variables. That's the name of the Windows VM, the admin user, and a very secret password. And then we create the VM. So we're providing the name, the resource group, the user, the password, and we're using the Windows 2022 image. And I'm also going to use a bigger VM than the default one, because the default VM only has 2 CPU cores, and this makes Windows very slow. And I want it to be a bit faster. And again, I'm querying the public IP address because I'm going to use the IP address in the next step to RDP into the VM and install the software. In this demo, I'm going to install first Chocolatey, and then with Chocolatey, we're going to install the .NET 9 SDK. And at the end, we are going to build a .NET 9 project to test if everything works. With the VM created, we can now open the RDP and we provide the public IP address. And this opened on my second window. Let's provide the username and let's paste in also the password. And let's connect to the VM. The first time you connect to the VM, it takes a couple minutes, but once you're in, let's search for PowerShell, and then we open it as admin. And in this PowerShell window, let's make this a bit bigger. We are going to install Chocolatey. And again, as always, I will provide you all the code I'm using today, so you don't have to type it. You can just download it from GitHub. And once Chocolatey is installed, we are going to use it to install the .NET 9 SDK. So Chocolatey is installed. And then we just use Choco install with the .NET 9 SDK. And this should only take like 1 or 2 minutes, I think, to download all the packages needed and then install the SDK. Installing .NET took way longer than expected, but once it's finished, you can use .NET version just to check if everything is installed. And as we can see, it tells us welcome to .NET 9. So that's good. That's everything I want to install on my VM. And now we can get the VM ready to use in our Managed DevOps pool. And unlike Linux, it's a bit more complicated. So first, we have to delete a folder. So let's clean this up quickly. So I have to delete the folder in the Windows folder and called Panther. And I have to admit, I don't really know why. It's just the documentation states that you have to do this. The next up, we're going to open the command line, again as administrator. And let's also zoom in there a bit. And now we have to enable the CD and DVD ROM. Again, I have no idea why you have to do this, but if you don't do this, the preparation of the image will fail. So let's just execute the commands as stated in the documentation. And once we have enabled the CD-ROM, we can move into the sysprep folder. And inside the sysprep folder, we have the sysprep.exe. And with this exe, we can generalize our image. And this opens this window. And then we can again say generalize and we shut down. This is now going to take a couple minutes. And once the image is prepared, the VM will automatically shut down. And then we go back into the Azure portal and continue with the next steps. The RDP connection has been terminated and this should mean that the VM has been shut down. So now let's move back to the Azure portal. And inside our resource group, if we scroll down, we should find the Windows VM. And here we do the same as with the Linux image. We click on the top on capture. And we capture the image. And now we share the image with the gallery we've created in the first step. So it already selected the resource group. Then in the gallery, we create the gallery you created. Then we provide a VM image definition. This means we have to create a new one. In this case, I'm going to call it my Windows agent. Everything else I'll leave as it is. Feel free to update it, especially if you want to share it publicly. You've down there more options to provide information for your customers. Then we provide a version number. This has always to be 3 digits, so I'm going to use 1.0.0. And everything else we can leave as it is for now. So let's review this. And then create. And now the image is added to the image gallery. This takes around 5 to 10 minutes. And once this is finished, we are going to create our Managed DevOps pool. And then we test a pipeline with the previously created image. Once the deployment is finished, we can create a new Managed DevOps pool. So to do this, we search on the top for DevOps and then we should find Managed DevOps pools. And there we already have the one we created before, but this time we create a new one. We use the same DevCenter and project. We provide again the URL to our Azure DevOps server. Then we provide the name for an agent pool. And the deployment will automatically create this agent pool in our Azure DevOps organization. We leave the region as it is. I just use one agent for this pipeline. Also with the agent size, you can use really big VMs if you have a big build and want to speed up. But for the demo, again, I use it as it is. For the OS disk, I use an SSD. So hopefully the demo pipeline builds faster. And then the most interesting part is down here, the images. So by default, the Managed DevOps pool selects Ubuntu, but we're going to delete this and then we're going to use our own image. So to do this, we click here on Add from Image Library. And then on the right side, we will click on Azure Compute Gallery Images. And there we have all the images we have in our gallery. There's the Ubuntu image from the previous demo and the Windows agent we just created. So we'll select this one and we add it. And then there are a whole bunch of more settings you can configure for Managed DevOps Pools, but for now we're just going to create it. If you're interested in all the details, I will link the video to the Managed DevOps Pool, and there you can see all the details and how to configure it, and also how to set it up using the Azure CLI. Now the deployment creates the agent pool in our organization, and once this is created, we can use this agent pool in our pipeline, and then Azure will automatically create a new VM with our image, add an agent to this VM, and then we'll execute the pipeline. So this should only take a couple minutes, and once the deployment is finished, we are going to test it. Once the deployment is finished, we can move over to our Azure DevOps organization, and there I already prepared a pipeline. So we are going to use this .NET 9 pipeline, and I'm going to start the pipeline, and then we're going to take a look how the pipeline is configured. So the first time you use a new agent pool, you have to give permissions. So we just click on permit and allow the pipeline to use the agent pool. Now it's going to take a couple minutes to create the VM with our agent, and then the VM will pick up the pipeline and execute it. In the meantime, let's take a look at the pipeline itself. And as you can see, it's very simple. The most important part is here the pool, and here we use the same name as we have configured during the deployment of the Managed DevOps pool. And then we just have one .NET task, and we build all CS_proj files. Executing the pipeline should only take a couple minutes. Usually it takes around 3 minutes to create the agent, and then I would guess 1 to 2 minutes to run the pipeline, but it can take up to 15 minutes to create the agent. And let's go back to our pipeline. And it hasn't picked up yet, but I will be back once the pipeline is finished. As you can see, the pipeline has been executed successfully. And this shows how easy it is to create your own image, install all the software you need, and then use this image to run an agent on it. And the great thing about it is that you don't have to manage anything about the agent. We didn't have to install the agent, provide a personal access token to get access to our Azure DevOps, or configure the agent. Everything was done by Microsoft. And with this, you can install whatever software you need if it's not available for the Microsoft agents, and then can easily build the software. This brings us to the end of the video. As you've seen, it is very simple to create 2 VMs, either Ubuntu or Windows, then prepare the VMs. It's a bit more complicated with Windows, but once you know how to do it, it's also quite simple. And then create a new image gallery and Managed DevOps pool, and then run a build with this image. If you're interested in how to script everything into more details, how to configure it, let me know in the comments. I'm happy to make a video about it. And if not, I hope you liked the video. If so, please like it on YouTube, share it, and I will see you next week with a new video.